Hello and welcome back to Calculus 1 section 3.7 chain rule part 1, because this is insanely important. So chain rule is the method that will take the derivative of function composition. So I'll write that in blood first. Chain rule takes the derivative of function composition. So technically, you are taking the derivative of f of g of x. Now, it's not just f of g of x, it's f of g of h, of k, of I. You can chain as many of these as you want inside. So we need to talk about pre-calculus first. We need to talk about function composition briefly so that we can actually talk about function decomposition, which is the part that we actually need to survive this. So function composition. Pre-calculus. Function composition in mathematics is denoted as f composed with g of x or f of g of x. And if it's written this way, it means plug g of x into f of x, replacing every x over them. But we'll take a look at that, the way this goes. So what I'm going to have here is, let's say, function f of x equals x sine 2x, and then I'm going to have g of x to be, let's say, square root of x minus 3. I can use these two functions and create f of g of x. Now, f is this x sine 2x. So when I am plugging g into f, you see how I replaced, this is very important to see now, very important to see, I am replacing this x with g of x. If I'm replacing that x with g of x, that means that each one of these x's has to be replaced by g of x. Because whatever you plug in here, you have to plug in for other x's. That's the cheapest way to learn this. So this becomes g of x sine of 2g of x. And then you just plug in what g of x is. And what g of x is the square root of x minus 3 times sine of 2 times square root of x minus 3. And now you have your function composition. You can also flip this around and find g of f of x, where you replace every x of g with f. And that would simply be square root of f of x minus 3, which would be square root of x sine 2x minus 3. So now you have seen the function composition done both ways. Now, some of you might be going, but why can I just have functions? Well, in nature, some functions get combined to provide new purpose. So if I pick can I borrow your backpack for a second? All right. Thank you very much. Look at this. This is a backpack, right? Now, we expect in this particular backpack to find books. Right? Because we see a student over here, right? Full books, notebooks, right? Stuff like that. Now, can I use this for camping? Yes. Can I put in the pans inside? No. And, some stuff? Yeah. And then it becomes, it changes. Is this still a backpack? But see, its function is different. Put a parachute in this one, right? You do it right. You jump out of plane, right? Still same backpack, right? You played PUBG, just put the stripes inside. Right? So the content of the backpack determines its purpose. So backpack has the function to hold stuff. So that's your F, right? That's the backpack. And its function is to hold stuff. G is the stuff that goes inside, and when you start changing G, it starts changing the purpose of the backpack. You stop in the parachute, right? You go onto the plane, jump out, right? Put in books, go to class, right? Put the camping stuff, go camping. So this is what problem solving 101. Anyway, so that is what the function composition is. And you are going to use in engineering a lot of function composition, right? Because you're going to have a module that does something, you combine it with another module, right? You put one on top of the other. Computer science geeks will have that in the programming, a lot of stuff. So yeah, so it's going to be a lot of function composition. Now we do not care about function composition, unfortunately. We care about function decomposition so that we can take the derivative. So what you are looking at here would be, you have some function y equal sine of 1 over x. The skill that we need from pre-calc, which you never practiced before, is to decompose this into f and g. That's what I need. Because once you are able to mentally do that, then these derivatives are going to, go fine and easy. So now, I like to call these outer and inner function, f and g, right? Outer and inner. And then we're going to have, 3 of them and, multiple, go on and so on. So let's see. What would be the main function, the outer function, the boss function? Sine of x, good. And then you plug in 1 over x inside that x to make sine 1 over x. Bueno. Y equals e to the negative x squared. F G. E to the x negative x squared. Perfect. Y equals e to the 1 over x over x. That's a spicy one.
1 over x. Oh, e over x and g will be 1 over x. To the x over x. E to the x over x.
Nope.
Oh wait, it would just be. Wouldn't it just be e? Oh no.
Yes?
X, e to the x. X, and then x is 1. X, e to the x. Yeah. But that just be possible?
No.
X, e to the x.
Yes! Nice! X e to the x, and this puppy is 1 over x. Haha! Because, okay, so now, what's happening here? I am making f of g, right, of x. So that's going to be my g e to the g, which is 1 over x, e to the 1 over x, which is e. Aha! See? Spice level 4. Yeah. That one is spicy. Okay, let's see what else we can. Yeah. No coffee. All right. Well, this one is just plain mean, but we have to do it. You can take the derivative of this, I understand, okay? But we're not talking about the derivative. We're talking about function composition, and I'm just being mean with this one. What do we do? No, we can actually write this. This is one of those things, don't fix it if it ain't broken. Or, use the sledgehammer to put the little nail into the wall, right? But you could use either a remote or something else. Okay. Anyone? No? So we need to somehow make some kind of core, right? That we can just kick out for G. So what could we transform this with? Yeah, I know, intermediate algebra was like
X plus 13.
forever before. So we're going to complete the square. X squared plus 4x plus 4 plus 9. And then these three puppies are going to give you x plus 2, everything squared plus 9. And now your f is x squared plus 9. And your g is x plus 2. Just because you can. Right? This is called flexing in mathematics. No reason for this whatsoever. It's just flexing, okay? Now, if you are to take the derivative using chain rule for the second part, and you take the regular derivative you guys learned 2 weeks ago from the top part, you're going to get the same answer. So absolutely there is no need to do something like this, but it's in the realm of possibilities. Now let's go and take a look at y equals 3 sine squared of x cubed. This is the next level. Why is this the next level? The previous one is mean and unnecessary, but this one is necessary. So why is this next level?
Two exponents.
2 exponents and a trig function. So what are you reckoning over here?
Sine squared x and 3x cubed.
Well, I don't like the sine and the squared together, because are they the same function? Are they the basic functions? Remember, your function composition is between basic functions. How many basic functions do I have? 3. You said it. I have 3 basic functions. Do we all see the function x cubed?
Yep.
Do we all see function sine x?
Yep.
Those are the easy ones to see. Now, do you also see x squared function?
Yeah.
You should, because I'll write this and then delete it. Sine squared x is the same as sine x everything squared. So doesn't this just look like x squared? It does, right? So now, when you are looking at to decompose this function, it's going to have 3 layers over here. So FGH, and maybe you can look at this as a layers of the onion, right? I don't know if you do cooking as much as I do, but the onion has those layers, and you just go a layer by layer by layer. So I'm going to rewrite this problem as 3 sine x cubed everything squared. This is extremely important. Maybe you want to put in a parenthesis that ln notation works the same way. If you see ln squared, that square doesn't go in front. That square is everything squared. So now, what is the boss function? The one that is the outer layer of onion, the one that you actually see. 3x squared, nice. 3x squared is the outer layer. Now, layer in is sine x, beautiful. And then the most inner, x cubed. So now, this x cubed goes there, then all of this goes there, and you get an inverted snowman. Let's try with red. So all of this goes into this x, and then with that, all of this goes inside this x right there to create that function. So this is a three levels. And this is the skill, guys, that you need to survive chain rule and the rest of calculus. Y equals square root of ln cubed of x plus 1. Think about it. Ready for the boss move? So this 3 on ln, the cube on ln, and the square root are actually the same order of the exponent. So this is just ln of x plus 1, everything to the 3/2 exponent. So f is the outer, x to 3/2. Then we go one level in for g, which is going to be ln x, and then we go h all the way inside of x plus 1. I don't need parentheses on x plus 1. So x plus 1 gets stuffed into ln first, and then ln gets stuffed into the x for 3/2. Half is the root, 3 is the power, so you can, yes?
Can there be more than 3 functions?
Say no more. I got you covered. I got you covered. Completely unnecessary, but. So, let's go with three sine squared of ln of square root of x plus 6 to the fourth power for a good measure.
What are the letters? F, G, H,
And sh.
I.
Use sh. Sh.
What about the fifth one?
Spell that. I just did. Sh right here. Sh. I can also give you j. Like if you don't know Serbian letters, I'll provide the Serbian letters.
Thank you.
My name has ñ in it, so here ñ. Ñ.
Oh yeah, I got some of that at home. What is that again?
I got some of that at home.
Put some hot sauce on that.
Put some hot sauce. All right, so what do we got? F, G. Yeah, I don't even know how many of these. So let's just talk. Do we all see a square? That's going to be one function. Do we all see a fourth? That's going to be one of them, right? We all see x plus 6. That's one of them. We all see the square root. We all see the ln. We all see the sine, right? So maybe we should just go to alphabet A, B, C. Because, right, sponsored by. So we start, so some people like to start in the middle and work their way out. Others like to start on the outside and work their way in, right? The derivative will be taken only one way, but the way you decompose the function, right, in your head is up to you. You need to know each stage when the new function begins, because each stage for the derivative will introduce another chain in the derivative. It just times another piece. So we say chain, but it's right, just another piece. So I am the one of the people who likes to start from the outside in. So I have 3x squared on the outside, because that square on a sine will be the one that makes this. And that's why this is 3x2 squared, right? 3 something squared. So that's where I start. And then I have to dig in 1, and that's going to be sine. So I have sine of x. Now, this x of a sine was raised to the 4th power. And this x, what letter should I use? I. The function I of x will be ln of x. And then the next one in, what's the next letter we use? J it is going to be square root of x. And the final one, k, is going to be x plus 6. And whoever said, I heard it, whoever said, this is going to have 6 one. Yeah, there they are. Claim it.
I got something different though. A little different. A little different.
Well, it's wrong. So now you copy this and you move on.
Wait, is it alright if I make G?
No. No.
I made it sine squared x. That's
No, because sine and a square, that's 2 different functions, right? You are only allowed to have one basic function per line. one basic function per level. Sine squared is already composition. I think we started with that example, didn't we? No, we started sine 1 over x.
How come the square root of x plus 6 and 4, you don't combine the exponents like you did in the previous example?
4 is on ln. It's not on a root.
The first function is
Did you find the square root of x plus 6? Or
what x is this like
X plus 6 is a separate function from this, because you remember, you're taking the basic derivative of root x, not of root x plus 6. Right? When you take a look at the basic derivatives, the basic chart has the derivative of root x. Now, there is a hack that you can do because you have ln. And the... What?
Yeah, I understand. She needs to stay straight. She has to fear.
You all see the square root? That's an exponent on x plus 6, which is the argument of ln. That one can jump out as a 1/2 and kill one of the functions. But that's already the boss level of, we have to upgrade to that point in life. So, yes, you can reduce this by a stage, but that one stage is going to push that 1/2 in front. And then, that takes care of that. But what I need you to see is that all of this is buried within the sine, and sine is buried within the square, right? All of that times 3 at the end, and so on. So this is the skill, right? And what you see here in Calc 2, right? The skill is there, so you can do the U substitution eventually. Because, I don't know if everyone can see this. You see the square root of x minus 2? It cannot be integrated. You have to use backwards chain rule, which is what we are learning now, and that's the U sub from 5.5. This is in your actually curriculum for this semester. It's heavily used in Calc 2, obviously, but right, we start. So let's go and do some derivatives now that you all have the mad skills. Let's see some chain rule. The first off is going to be the formula. And the formula for chain rule looks like this. The derivative of f of g of x is f prime g of x still plugged in times the derivative of g of x. So this is your chain rule formula when you only have two functions. Now, we'll do a ton of examples, but let's see the alternate version. And the alt version of this one is saying this. F of g of x, and I'll put the prime on it right there. I can actually put d dx in front. Nah, I'll put d dx in front. Just because I see some of you are writing with pens, and it's gonna ruin your day. Move this down a little bit. So you are going to take the derivative of f. You're going to take the derivative of f in respect to g, and then take the derivative of g in respect to x. Now, that's a weird notation, but it also provides the insight into the method. And the second one is better when you have multiple functions, but let's deal with two first. Now, The goal is to take the derivative of f in respect to x. That's the ultimate goal, right? You see that when I cancel dg's, you exactly get df dx, right? That's the ultimate goal. Anyway, let's take a look at some of the derivatives. So what is the derivative of sine of x cubed? Well, decompose in my head. I have sine x and x cubed. Knowing that this x cubed over here is the g, and this one is f, right? So I am supposed to take the derivative of f with g plugged in. So what's the derivative of f? Cosine x. But it has to be cosine x cubed, because g needs to stay plugged in. And then times the derivative of that g, which is 3x squared. And then you simplify this into 3x squared cosine x cubed, and that is the derivative. You remember how you memorized the formula that the derivative of e to the ax is a e to the ax? Remember that formula? Let's actually use chain rule to prove it. How about the derivative of e? Well, this is not a proof, it's an example. To the 3x. What's the derivative? What is my my f? E to the x. And what's my g? 3x. Bueno. So, when I take the derivative of f, what is it? Well, the derivative of e to the x is e to the x, so e to the 3x, times the derivative of g, which is 3, and you get your 3e to the 3x. So now you can forget the formula, because you can do these things. It's going to get some time to use to this, but eventually. What is the derivative of ln of 6x squared? So what's my f? ln x, bueno. What's my g? 6x squared. That's a basic function, guys, right? It's a basic function. You can take the derivative of that without any witchcraft, right? Just basic derivative. So what is the derivative of ln? 1 over x. But remember, it has to be 1 over g, right? Because every x becomes g. So 1 over 6x squared times the derivative of g, which is 12x. Beautiful. Put this together, you get 12x over 6x squared. What do we get? 2 over x. 2 over x. This tells us that we should be able to manipulate this somehow, the original problem, to have an easier derivative. Right? Right.
Oh, the ln squared, right?
Yes, but there is a 6 in a way. So? So, the derivative of ln 6x squared. Now we're going back to pre-calculus, And remember the formula, when you have a multiplication inside the argument, it becomes the addition of two ln's. So this is going to be the derivative of ln 6 plus ln x squared. And what's the other formula that I need? The 2 jumps in front of ln x. Now, what's ln 6? What is ln 6? A constant. And what's the derivative of a constant?
0.
Here's a potato right there. Plus 2 times, and what's the derivative of ln x? Yes, 1 over x, which is 2 over x. This is why you should always have a pair of shades on you. When problem like this comes up, and you pull this off instead of chain rule, right? Pop those on. Of course, cool, it's math. Oh, you can do the chain rule, right? This is just, again, flexing in mathematics. Let's take a look at the derivative of a cube root of x squared minus 2. So try this one on your own. What's f? Cube root of x, beautiful. Which can be written as x to the 1/3 for purposes of derivatives, right? What's g?
X squared minus
The whole thing, yes. X squared minus 2, you cannot break that down any further. So what is the derivative?
2x over 3 x squared minus 4x cubed.
So let's do it this way, right? You say 1/3 drops down, right?
Yeah.
And then you have something to the negative 2/3. Would this be like if this was an x over here? Would that be the derivative of this? Do we all agree? We all agree, right? Now, if you look at the formula, it says not x, but you have to have g of x in there. So that's why I leave that x out, so I can plug in what g of x is. And that's x squared minus 2. Now I call that guts. So here's the guts. And then the chain is the derivative of the guts, which is 2x.
But everything on the left goes in the boundary.
No, you were completely right. I'm not gonna fight. So it becomes 2x divided by 3 x squared minus 2 to the 2/3. We just need to have a teaching moment, but you got it. Keep it. Why do we want it simplified? 2 reasons. Number 1, chapter 4 is coming. This is your first step, equal to 0. Go on with your problem. So that's chapter 4. And then reason 2, as always, we have computer science people around. And they need the simplified answer because less mathematical operations, less calculations computer has to do, faster the software. So it's called optimizing. So one more example and we are done for tonight. We will pick up the next class to do the second and the third level. Right? We talked about the layers of hell, right? So we'll just completed the first 2, 3. So we'll have to descend more next time. So the derivative of no coffee. I don't even know what to put anymore over here. E to the sine squared x. This is the good night one. How many functions?
3.
3. I need the pros over here. F is?
E to the x.
G is?
Sin x. No, x squared. Sin x and then sin
Ah,
x.
yes, x squared, nice. And then?
Sin x.
H is sine x, nice. So, the derivative is E, it always stays the same. So Control C, Control V. Times the derivative of x squared is going to be 2 sine x to the first power, and then times the derivative of sine is cosine x. What's 2 sine cosine x? That's where it reflects a little bit, right? Gives us e to the sine x squared times sine 2x. Or you can put sine first, e later, whatever. The title for Tuesday? Yes, the return of the chain rule. Or, no, the revenge of the chain. Ha ha ha, the revenge. The revenge for the next class. Come on.
It depends what you're talking about. Star Wars or
Oh, very fair point.
The revenge of the chain rule. So that's for the next. That's going to be the part 2.
So Nick.